Now we have obtained Van Hoff reaction isotherm. Okay, Van Hoff's equation. This can be rearranged as d ln Kp is equal to delta H0 by RT squared into dt. So if we integrate this between limits 1 and 2, we can write integration between Kp1, Kp2, d ln Kp is equal to delta H0 is a constant, R is a constant, integral T1 to T2 dt by T squared. This can be integrated as ln Kp is ln Kp between limits 1 and 2 is equal to delta H0 by R into integral dt by t square is minus 1 by t between limits t1 and t2. This is ln Kp2 divided by Kp1 is equal to minus delta H0 by R into 1 by T2 minus 1 by T. This is the integrated form of Van Hoff's equation. Okay. So we have d ln Kp by dt is equal to delta H0 by R T squared. Okay. So what is the relationship between Kp and Kc? Kp is equal to Kc into RT raised to delta n. Okay. So what is ln Kp? Ln Kp is equal to ln Kc plus delta n into ln R plus delta n into ln T. Ln T. Okay. Now what is d ln Kp by dt? Let it be at constant pressure. This will be equal to d ln Kc by dt at constant pressure plus this term does not have a temperature term, therefore it cancels out, plus delta n into d by dt of ln T is 1 by T, delta n by T. Okay, but what is d ln Kp by dt at constant pressure? That is delta H0 by R T squared is equal to d ln Kc by dt at constant pressure plus delta n by T. Now let's rearrange d ln Kc by dt at constant pressure will be equal to delta H0 by RT squared minus delta n by T. Now delta n by T can be rearranged as delta n RT by RT squared. Is it right? Cancel this. Here RT cancelled. Here R and T square cancelled. Therefore, this is delta n by T. Now, this can be written as delta H0 by RT squared minus delta n into RT by RT squared. Okay. But we know that delta H is equal to delta U plus P delta V. What is PV? PV is equal to nRT. Okay. So what is P into delta V? This can be written as delta N RT. So delta n RT can be substituted for P delta V. Therefore, this equation becomes delta U plus delta n RT. Okay. So what is delta H now? Delta H is equal to delta U plus delta nRT. So what is delta H0? Delta H0 is equal to delta U0 plus delta nRT. Or what is delta U0? This is equal to delta H0 minus delta nRT. Okay. Here we have delta H0 by RT square minus delta nRT by RT square. This can be written as delta H0 minus delta nRT divided by RT square. Now we have substitution for delta H0 by delta H0 minus delta nRT. Therefore, dln Kc by dt at constant pressure can be equated as delta U0 by RT square. And this equation is known as Van Hoff reaction isochore. Van Hoff reaction isochore. This is not at constant temperature. This is at constant pressure. This equation gives the variation of equilibrium constant in terms of equilibrium constant in terms of molarity with temperature at constant pressure. This equation is known as Van Hoff reaction isochore. What is Van Hoff reaction isotherm? This equation is known as Van Hoff's reaction isotherm. Delta G is equal to minus RT ln Ka plus RT ln Q. Students always used to confuse between these equations. Possibly you will write d ln Kp by dt is equal to delta H0 by RT square as equal to the Van Hoff reaction isotherm. This is not at constant temperature. This shows the variation with temperature. Therefore, this is not Van Hoff's reaction isotherm. This is Van Hoff's equation. What is Van Hoff reaction isotherm? Van Hoff's reaction isotherm is delta G is equal to minus RT ln Ka plus RT ln Q. And Van Hoff's reaction isochore is the equation that we derived just now. d ln Kc by dt at constant pressure is equal to delta U0 by RT square. Integrating this equation like we did before, we get ln Kc2 by Kc1 is as equal to delta U0 by R into 1 by T1 minus 1 by T2. Okay. Now we'll discuss about the consequences of these equations in the next class. Thank you.